Question about number 39 from the homework. Alright, so this is the physics problem for point 30 yards directly in front of the goalpost, that one, out of the online book. Suppose the initial velocity of the ball is 60 feet per second. Alright, sorry, your Chromebook's not in here. 60 feet per second, and the angle of elevation is 30. Find an equation in x and y that describes the path of the ball. Alright, okay. So let's see here. Okay, so x, and if we think about it, remember that the ball is being kicked like this up in that direction there. Okay, so the x coordinate is going to be this, so it's being kicked at a find a path of the ball. Okay. Okay, well, they gave us the equation already. Okay, sorry, I was just looking back. So they gave us this equation, and they gave us this equation that we're going to use. Sorry, I just had to go back and read it. Okay, so 60, so 60 is going to be the v there, and cosine of 30, t, and that's my x, so cosine of 30, that's going to be root 3 over 2, so that's going to be 30 root 3 t, that's my x right there. My y, v again is 60, right? Sine of 30 is 1/2, so this is going to be 30t minus 16t squared, that's y, okay? And so find the equation, so that's part A. Now we're on to part B. The goalpost crossbar is 10 feet above the ground. Under the conditions stated in part A, will the ball pass over the goalpost crossbar? Okay, so keeping in mind that from the diagram, it's going to be 30 yards or 90 feet away. So let's see. Let's make sure x is in feet here, right? Oh, yep, that's in feet. Okay, all right. So if I take a look at it, all right, basically I want to know, right? Basically, it's going to be the point 90, 10, 90 feet away, right? But it needs to be 10 feet up for ourselves there to cross over, okay? Okay, so if I'm taking a look at this, and let me set x equal to 90, okay? So when I'm 90 feet away, let's figure out the time that that's going to occur. So I'll divide by 30 root 3, okay? And I'll get my t, all right? So it's going to be 3 over root 3. Okay, yep. And so when I reduce that one down, that's going to be root 3 for my time, which is about 1.7 seconds or so. Right, my calculator right here. I'm going to get more decimals for it, square root of 3. So 1.7321. I'll get 4 decimal places. Okay, so that's the time that I'm going to be at 90 feet. So let me go and plug that in over here. All right, think about y is going to be when I plug in 1.7321, or basically the square root of 3. So it's going to be 30 square roots of 3. Let me just use square root of 3. Right, minus 16 times 3, right, because it's square root of 3 squared. So, right, so it's going to be 30 root 3 minus 48. Okay, so I'll put that into my calculator. 30 root 3 minus 48. I get 3.96 approximately. So when it's 90 feet away, 30 yards away, right, it's only going to have a height of 3.96 feet. So the answer would be no for that one. Right there. Okay, will it pass over the crossbar? No, it will not. Okay, looking at part C. To simulate the motion of the football, use a computer or graphing calculator to graph the parametric equations when you have this. Okay. Right, write the parametric equations you can use to represent the goalpost with a vertical line segment. Okay, so basically for C here, right, you go into your calculator, right, and you don't have to get rid of it, but we're going to just change our mode, and we're going to change it, mode, right, I'm going to change it to parametric mode. See how we're in function mode? We're going to hit pair to put it in parametric mode. Right, so hopefully you can see that. Okay, then when you go back to y equals, you're going to have equations there, so you can get rid of those and you can put your equations right in there. Okay, and so this can kind of show you the path it's going to take. So my equation there is going to be 30 square roots of 3 times t for the x, and for the y I'm going to put 30 t minus 16t squared. Okay, and let me just make sure I change my windows to something reasonable. Right, it's going to go up. I need to go up to 90 because that's where I'm trying to hit. Actually, let's go up to 100 so I can really see it. And I'll have it go up by every 5. Right, my step is going to go up by. Oh no, it's going to go up by 1. That's going to be how often it puts a point. Right. Oh, okay. Oh, these are the t's. I'm sorry, these are the t values. I don't need my t values to go up to 100 then. I need my t values to only go up to like 2, it looks like. And I'll have my t steps as 0.01. So it's every 100th of a second it's going to do. So my x min is going to be, I'll do -1, and then my x max will be 100, and I'll have to go up by 5s. Okay, for my y min is 0 with a height of 40. That's the peak of it. Right, so that seems reasonable. If I graph it, right, I'll see the travel of the football as it goes there. Okay, for myself. And so that's all C is asking us. What parametric could you use to represent the goalpost with a vertical line of 10? Okay, so what parametric equation? Well, I just want the y value to be 10, so I'll just put 10 there for the whole thing. Right, for the x value, yeah, I'm just going to make it equal 10. See if that graphs. I think that will work. Okay. Right, and see if it graphs it. I may need to go back and put something in for the x. Okay. Yep. Let's just put the x value. That's just. Oh, I need to know where the x value is going to be. That's going to be the t value there. Okay. Now we'll graph that. Okay. Now we actually have a point. You need to know where the x and the y are going to be. So the x is going to be whatever t value I have. Okay. I might need to change my window here. Yep, I need my t max then to go up to 100. Now when I graph it, it should work. Let's try it one more time. Oh, you guys can't see that. Sorry. Okay. Now I should see that line come up. Please come up this time. It's still graphing because this one's going way out there, right? So it will eventually do it. One of the things I could do here is I could change this, put my window back to, instead of just have it go up to 2, and then when I do my equation, maybe have this be like 100t, and then that should. The reason it was taking so long is that I was going really high in t value, so it's just plugging in. My older calculator has trouble with that. All right, so there we go. Okay, so now we can see, hey, there's that. So if we trace it, see, there's the height of 10 feet. So, and you can see that it dipped down pretty soon. So there's my equation that I could use. So C, my x equation could be something. Okay. Part D, keeping the 60 feet there, vary the angle to the nearest degree, find the minimum value that will allow the ball to pass over the crossbar. Right, for myself, so I can basically just change that angle there. And it tells me to do it with a graphing calculator. So you just kind of plug some values in and see what you can get. Right, so I'm going to go back to my equation here, right, and try to mess around with that a little bit. And so let's see, and I'm going to do like 60 cosine, and if you're doing this on Desmos, you can make a slider out of it, and it's a lot easier. If you're using graphic calculators, it's a little annoying, right? Let me make sure I have my mode. Yep, I'm in degrees. Okay. Nope, I don't know if you can hear Moose in the background there crying, right? Let me try 45 degrees, right? And this is all I'm going to really try. I'm just going to plug some numbers in and see what happens there, right? And so 60 sines of 45 minus 16 t squared. Okay, I'm going to leave those other two there so I can really see like where it crosses over. Right? Much different graph for this one. Okay, so you just kind of play around with those until you get one that works, and that's how you do part D there.